video, we're going to evaluate trigonometric ratios in special triangles. Hi, so I had talked in one of the other videos about three special triangles, a 40-40, 45-45, 90, a 30-60, 90, and 60-30, 90, while the 60-30 and the 30-60 are essentially the same triangles. It just all depends on what angle you're looking at. So we really have two special triangles, the 45-45, 90, and the 30-60, 90. And in this one, we're going to look at how and why these are special. So we're going to begin that exploration. So we have a triangle M, N, and O. With M, N, O. We have a 90 degree here. This right here is 2, and we have theta right here. Okay, what is the isosceles right triangle so that the legs are congruent? So first, we have to find the hypotenuse using the Pythagorean theorem. Well, this is an isosceles right triangle, so if this is 2, then this is 2 as well. And now we're looking at, again, using Pythagorean's theorem, a squared plus b squared equals c squared. So this is 2 squared plus 2 squared equals c squared, which is going to be 4 plus 4, which equals c squared, which is 8, which equals c squared, which is going to be the square root of 8. Again, not plus and minus because we're working with length. And then 8 can be reduced to 4 times 2. The square root of 4 is 2 times the square root of 2, which is going to be our hypotenuse. So I'm going to grab a different color and say this is 2 root 2, indicating that the red is what we found. All right, so the side lengths of M to O is equal to 2, and to M is the square root of 2, or 2 over 2 square root of 2, and O to N is 2. Okay, so looking at this, let's find our ratios. I'm going to start with sine of theta. This is going to be the opposite over the hypotenuse. These will simplify out. We get 1 over the square root of 2. Don't really like the square root in the denominator, so we're going to rationalize that by multiplying both the numerator and denominator by 2, and we're left with the square root of 2 over 2. Again, these are special triangles, so these are numbers that you would want to start remembering, that the sine of theta is the square root of 2 over 2. The cosine of theta equals the opposite over adjacent. And this is actually for a radius of 2, and we'll get more into that. This, again, we did the work up here. This will be the square root of 2 over 2. Tangent. Remember I told you in one of the videos that tangent of theta is going to be sine over cosine? And sine over cosine in this case is going to be square root of 2 over 2 divided by the square root of 2 over 2, or 1. You could also see that it's opposite over adjacent, which is 2 over 2, which is 1. The cosecant, CSC, of theta is going to be the reciprocal. So that's going to be 2 square root of 2 over 2, which is just going to be the square root of 2. The secant of theta is going to be, again, the reciprocal of here. So that's going to be 2 root 2 over 2, which is going to be root 2. And then the cotangent is the reciprocal of 1. The reciprocal of 1 is just 1. So in a 45, 45, 90 degree triangle, since the two legs are equal, sine of theta equals cosine of theta. So this is for 45, 45, 90. Sine of theta is equal to cosine of theta. Cosecant of theta is equal to secant of theta. And tangent of theta is equal to cotangent of theta, which is equal to 1. All right, so you could check your calculations. You could use the calculator to evaluate 45. You will actually get the square root of 2 over 2, and if I'm right, that's 0.707. So square root of 2 divided by 2 divided by 2, and yes, it's 0.707. So if you were to plug this in, this guy right here is 0.707 on the calculator with some other decimals following. It's not just 0.707. It has other decimals trailing it. All right, so I told you there are two different triangles, so let's investigate the second triangle of 30, 60, 90. So here's my 90. Here's my theta. We're going to use 8 for my hypotenuse, 4 for the leg. And we need to find the other leg using Pythagorean's theorem. We get 4 root 3. All right. So now that we have that, we're going to base it off of this angle. No, I lied, not that angle. This angle right here. Let me erase this angle up here. That's not an eraser. That is still my marker. All right, so here we're going to base it off the angle down here in this bottom right corner. And if I were to look at this, I'm going to do sine of theta, which is opposite over hypotenuse, which is going to be 1/2. Then we have cosine of theta, which is going to be adjacent 4 root 3 over 8. That simplifies to root 3 over 2. Tangent of theta is going to be 1/2 over, 1/2 over root 3, which is just going to leave us with, let's see, actually I'll do it like this, 4 over 4 root 3, which equals 1 over root 3, and because we're in Algebra 2, we have to rationalize this. So multiply root 3 to the top and the bottom. We get root 3 over 3. Cosecant of theta is going to be the reciprocal of 1 over 2, which is 2 over 1, which is just 2. Secant of theta is going to be the reciprocal of root 3 over 2, so that's going to be 2 over root 3. Again, Algebra 2, we need to rationalize the denominator. Take that root out of it, that square root, so we get 2 square root of 3 over 3. And then tangent, I like how I put tangent instead of cotangent. Cotangent of theta will then be the reciprocal of this, which is 3 root 3. Actually, it's easier to just write from the beginning instead of having to rationalize in our case. 4 root 3, I'm taking this piece right here, dividing that by 4, which is just going to be root 3. Again, these are values that you will want to remember, because these values will show up over and over again, and we'll investigate how they show up over and over and over again. All right, so values you want to learn, want to identify, want to be able to see. And guys, this is it for this video. I will catch you at the next video. Again, if you have any comments, please always feel free to ask, and I will see you later.